Okay, yeah. So, hi, my name's Eric Becker. I'm the in-house engineer at the WWF US office. I'm part of the wildlife team, and I work on the wildlife crime technology project, where we focus on research and development of any kind of technology that'll help park management and rangers better secure and protect wildlife, but also help mitigate any human-wildlife conflict. I've been working with WWF for about 4 years now. A lot of my time I spend in the field going on patrols and ambush missions, or just really spending time on the ground with rangers to try and understand their challenges and try and see where we can develop or maybe integrate some technology solution into their operations to help them be more efficient, more effective, but also safer, really. I'm not sure of how many people are familiar with the zero poaching model, but this is an open model that you can find on the internet that was developed by a group of partners in WWF. But it basically is a model that calls out all the different pillars that need to be addressed to really achieve zero poaching, even though a lot of people don't necessarily like the name. This is the model we tend to follow when approaching these protected areas. And with our technology project, we obviously focus on the technology side, or boosting the technical capacity or technology capacity of the rangers on the ground. As far as challenges, we see kind of these common challenges that rangers experience in most protected areas. There are some cases where maybe the capacity is a little bit further along or more advanced than some of the protected areas, but a lot of times the poaching happens at night. Protected areas are vast, sometimes the size of states, or and a good example is I'm working in a park that's the size of Massachusetts, and they have 103 rangers that patrol that area. So it's just a vast area with very limited manpower. There's no real reliable source of power in the field. There's no real ability to respond in real time in a lot of these protected areas unless they have access to a helicopter. They have very, very limited access to voice communications. Sometimes there's some spotty cell phone coverage or cellular coverage in these protected areas, and then some have limited coverage from like analog or digital radio networks, but communication is a big challenge for these protected areas. As far as working in the field from the tech side, deploying these technology projects, I'd say the most critical thing that I didn't list on here is just working with the rangers and park management from day one, and just make sure that they have invested interest and you keep them involved from throughout the design cycle when you're trying to develop a solution, and really having their buy-in. Parachuting into a place with the solution in mind isn't necessarily the best, I guess, approach. A lot of times you'll find that the tech solutions need to be customized to the specific environment. So there's not necessarily a silver bullet for everything. Another thing that was kind of unique for me, which is kind of obvious when you think about working in these protected areas, is the wildlife proofing and the game proofing. And just making sure that whatever you deploy can survive in these types of environments. There's also limited to no access to any kind of spares or electronic components or wires or whatever it might be, as well as weatherproof enclosures or any kind of mechanical hardware you might need. So whenever you plan on deploying these types of technologies or any kind of system in these protected areas, bringing in all kinds of spares and any kind of tool is required, because you'll end up doing some in-field modifications. There's limited on-site technical expertise. Again, there's some cases where they have IT personnel on staff full-time, but a lot of times you'll be training people that have never even used a computer in their life, and just trying to boost that capacity is another critical thing, especially for the sustainability of these projects. This is just an image of some of the networked thermal cameras that we deployed in Kenya. And this is one where a baboon decided to jump up and down on our panels and snap them off. And again, this was maybe 10 days after I installed the system, and then we just came up with a novel game-proofing method of putting some grease on the bottom of the pole. I'm not sure if you can see that on the bottom right of the screen. But just, again, making sure that whatever you deploy in these parks can survive the curious wildlife that are going to mess with your technology. So again, I'm part of the Wildlife Crime Technology Project. We started in 2013 with when we received a Global Impact Award from Google.org, and that grant finished in the beginning of, I think, 2016. But the focus of that effort was to really try and flesh out what types of sensors or technology would work in these environments. And the initial goal was, how can we use UAVs or drones to stop poaching? And what we quickly realized is, I mean, UAVs, they might be part of the solution, but they're not the answer. And mainly it's due to the cost of the platforms, the flight time, and then the size of the area that we need to cover. So we quickly started looking at what other types of sensors could we use, or whatever type of technology could we use in the field that, again, will be a force multiplier, give the rangers the granularity of the resolution that they need in real time to respond to these alerts. So we investigated all the different modes of sensing: acoustic, seismic, radar, different types of night vision technology. But basically honed in on the fact that a lot of the poaching happens at night, and we needed to really just be able to deploy sensors and give the rangers the capability to see at night, but deploy sensors that were long range and accurate enough to detect these, what we cared about, the humans, and then also wildlife leaving the protected area, but be able to do it at long range at night, again, to try and minimize the number of sensors that we needed to deploy in these areas. And we ended up focusing a lot on thermal cameras. I'm not sure if everybody's familiar with thermal imaging, but just real quick, thermal cameras pick up on light in the long wave infrared or in the infrared spectrum. And that's basically, how do I say this? Warm objects, or they can arbitrarily map the temperature reading in these frequencies to any color that we want. And what that means is you can map out or bring out living things and how do I say this? The living things are high contrast in the video, which makes it easy for us to train and run machine learning or classifiers to look for things that we care about, but also makes it easier for the human eye at nighttime to see these living objects or targets at long distances. For the thermal cameras, and I apologize for talking so fast, but I'm just trying to cram a lot in the time I have. For the thermal cameras, we deploy the static fixed cameras along boundaries, which are the networked cameras. We also deploy scanning 360 fixed cameras that, again, are networked, and they have an onboard single board computer that looks for things in the different presets, so it can also look for humans while it's scanning 360 degrees. We also are deploying the multi-rotor UAVs partly for human-elephant conflict or human-wildlife conflict, because the wildlife tend to hate the sound of the UAVs and the weird object flying overhead. But we also use them as a rapid response tool. So again, once you deploy any kind of technology with any kind of security system, you want to be able to respond as quick as possible, ideally within the amount of time it takes the target to leave your sensor's field of view. So maybe if it takes a human or a poacher to cross your sensor's field of view in 5 minutes, you want to try and be able to respond within 4. So to meet this type of requirement, we're starting to integrate UAVs as the quick rapid response tool to get eyes on the intruder or whatever it might be in near real time. We also use the thermal cameras, the radiometric version, which are just calibrated thermal cameras, and those allow us to see or to get accurate temperature readings from each pixel of the scene. And we are using those for habitat monitoring, wildlife monitoring, and also just trying to investigate on other ways we can use this kind of high sensitivity temperature reading and high resolution temperature reading. We also give the rangers handheld thermal cameras and mount them on vehicles, and the vehicle acts as kind of their drone on the ground or their eyes in the sky on the ground. And they can go and park on a hillside or wherever it might be and scan a large area and look for any kind of intruders. And maybe I'll skip the videos just because, and I can share these videos if you guys are interested. Just to speed things up here, I'll run this one. So this is a video that we captured about 10 days after I installed this camera system in Kenya. And this is the machine learning of the human classifier drawing the bounding box, the red bounding box over what it's classifying as a human. And right now there would be an alert going off in real time. And then you can also script however you want those alerts to be broadcasted, with whether you want it to be pushed to mobile or just through email or whatever it might be. But the reason why we are focusing on analytics is as we scale these systems up, we can't really burden the rangers with monitoring each feed 24/7. So we're heavily relying on analytics to kind of automate all the filtering and only show the operators what we care about or what the computer thinks is meaningful. So then this leads to our kind of most recent deployment where I just returned from Zambia and installed a network of cameras. But this is a collaboration with Cisco Systems and FLIR, and this is, I think they brand it as their connected conservation effort. And with this, we're basically kind of trying to integrate everything together. So we have a control room that has a server, and then we have a microwave point-to-point high bandwidth backhaul that connects our mast. And on our mast, we deploy the long-range thermal cameras, the short-range kind of optics, any kind of wireless gateway, whether it's LoRa or Wi-Fi, and basically build out the infrastructure and provide this network coverage. So now we can start enabling future deployments of technology. So right now we're in the network build-out phase where we're just installing all of, again, the infrastructure. And we're hoping here within the next few months, the system will be live to where we can start bringing in other tech developers to try and see how we can leverage this narrowband LoRa network as well as the high throughput microwave links and Wi-Fi. So again, this is just some images. This is a control room. This is in a very remote area in Zambia where we had to put a cold storage room just for our sensitive equipment that's in our equipment room. And I can get into more of this once, I mean, if you guys have questions. But again, basically everything we have to bring with us. And then this is an image of one of the islands or the mast sites of this system. And it just shows you the kind of, I guess, tech deployment that we're looking at doing now to where we can, again, use this infrastructure to scale and test and flesh out other tech that we can use for whether it's human wildlife conflict or security. And then this is just an image showing the quick integration of one of the FLIR's, the Duo Pro R that, again, has everything integrated. And I like this camera because the integration's easy. Again, all you have to do is apply power, and then you can go and attach this to your UAVs, and it geotags, or it tags the images with all the metadata, the orientation of the aircraft and its position. And it makes it easy to use this camera for generating thermal maps or orthomosaics, thermal and visible. And then the last thing, this is just kind of just a mention. I'm not sure how many people are familiar with the snare crisis, but snares are used as an indiscriminate killer of wildlife. And we are working on a method to detect these snares. They're very hard to see with the human eye, so we're looking at developing a radar solution to detect these metal snares. And we've kind of progressed through the different radar techniques and ultimately ended up at where we need to build an imaging radar and put it on a drone and fly and do synthetic aperture radar or develop a synthetic aperture radar and do change detection. And we're in the process of building that drone and testing it, and hope to fly here at the end of the month, and hope to post an update on our status, but it's showing promise of being able to detect snares. So yeah, that's my 100-mile-an-hour speech. I think I may have gone over time, so I apologize for the overshoot.